So what is given here? Autocorrelation function of xt is given. It is e power minus a mod tau, and yt is given. It is xt times cos omega t plus theta, where theta is uniform random variable over minus pi to pi. What is the density function of a uniform random variable? 1 by b minus a. So pi minus of my plus it is 1 by 2 pi over a range minus pi to pi. Okay. Now what we have to find? Determine autocorrelation of yt. So we should find r double y tau. This one we have to find. Okay. So let us proceed with the known formula of autocorrelation function. R double y tau is equals to the autocorrelation formula is expectation of xt. Here in place of xt we have y. So we have to write yt plus tau. We have practiced with x. Now y is given. So we in place of x we should write y. So expectation of yt plus tau. Now it is expectation of r double y tau is equals to expectation of, let us write yt. Yt is xt cos omega t plus theta and yt plus tau. So in place of t we have to write t plus tau. So it is x t plus tau cos omega t plus omega tau plus theta. Let us write expectation of xt plus tau cos omega t plus theta cos omega t plus omega tau plus theta. Now can someone tell me, can I write xt and xt plus tau outside the expectation?
No, sir. Independent counts.
We cannot write. It is expectation of xt plus tau. Okay, and we can write this another one cos omega t plus theta cos omega t plus omega tau plus theta. Right. So what is the first one? This one. Is it not autocorrelation function? It is autocorrelation function. So we can write it as r double x tau and expectation of, let us multiply and divide with 2 so that we can apply 2 cos a cos b formula. What is 2 cos a cos b formula? Cos a plus b plus cos a minus b. So let us multiply and divide with 2. So we get cos a plus b. Cos a plus b is 2 omega t plus omega tau plus 2 theta plus cos a minus b. Omega t and theta gets cancelled. It leaves us omega tau. Okay. Any doubt in this up to now? So r double x tau by 2 expectation of cos 2 omega t plus omega tau plus 2 theta and r double x tau by 2 expectation of cos omega tau. Anyway, theta is a random variable, not omega is not random variable. So cos omega t is constant. So expectation of cos omega t is cos omega tau is expectation of cos omega tau is cos omega tau only, because omega is constant. Okay, now let us write it as r double x tau by 2. Now let us apply the formula. Integration from minus pi to pi cos 2 omega t plus omega tau plus 2 theta f of theta d theta, and here r double x tau by 2. Expectation of constant is constant only, cos omega tau is constant, right? Integration of a sinusoidal signal over a cycle. What is that? What's the value? Can someone tell me?
0.
F of theta is how much? 1 by 2 pi. So let us write it outside. Minus pi 2 pi cos 2 omega t plus omega tau plus 2 theta d theta plus r double x tau by 2 cos omega tau. So this integration is 0. You do it. So the first part is 0, 0 plus r double x tau by 2 cos omega tau. Already it is given that r double x tau is how much? It is given. It is e power minus a mod tau by 2 cos omega tau. This way you have to find the autocorrelation function. So any doubt in this problem? Just I applied the formula and proceed according to the concepts.
సార్ అక్కడ స్ప్లిట్ చేసిన కదా ఎక్స్పెక్టేషన్
అవునన్నా,
అది ఎట్లా వచ్చింది సార్?
xt అనేది ఒక random process and cos omega t plus theta is omega and theta.
రాండమ్ వేరియబుల్
That's why, that's why I applied expectation on cos omega t plus theta. With respect to x, cos this omega and theta, they are different. They are corresponds to y. We can split it. With respect to xt and xt plus tau, we can split this cos omega t plus tau. Omega and theta are different. They corresponds to yt.
రాండమ్ ప్రాసెస్ ఇంకా రాండమ్ వేరియబుల్ ని స్ప్లిట్ చేయవచ్చు.
Okay. Yes. Did we discussed about joint Wilds and stationary random process? Can someone
sir.
answer? Did we solve any problem on that?
No sir, only
What are the conditions for a joint Wilds and stationary random process?
Individual random process should be white and stationary, and cross correlation should depend on time delay.
Very good. So now let us solve one problem on that. Let xt is equals to a cos omega t plus b sin omega t. Another random process yt is equals to b cos omega t minus a sin omega t, where a and b are random variables. A and b are random variables, and omega is constant. Show that xt and yt are jointly wide sin stationary. If a and b are uncorrelated, with zero mean and same variance, xt and yt are given. In that a and b are random variables, omega is constant. We should prove that xt and yt are jointly wide sin stationary random processes. Given conditions are a and b are uncorrelated with zero mean and same variance. Okay, so let us write the given data. A and b are uncorrelated. What is mean by this? How to express this?
Expectation of A into B is equal to expectation of A into expectation of.
Uncorrelated means the expectation of AB is 0. Okay, uncorrelated means expectation of AB is 0. Zero mean is given. Zero mean means the expectation of A is 0. Expectation of B is also 0. Okay, and same variance. Same variance means variance of A, variance of B, both are equal. Let us take them as a sigma square. Okay, so to prove that these two random processes xt and yt are jointly wide sin stationary, first condition we have to prove. What is the first condition? Mean. Or otherwise we have to prove that individually the xt and yt are wide sin stationary. Okay, so let us find out the mean of xt. Let us check the mean of xt. What is this? Expectation of xt, right? Am I right? Am I correct? Mean means expectation of xt, right? So expectation of what is xt? It is a cos omega t plus b sin omega t. Expectation is always applied on random variables. So expectation of a cos omega t is constant because omega is constant. It's not a random variable. Okay, cos omega t is a variable, but it is not a random variable. Do you understand the difference between variable and random variable? And the expectation of B sine omega t is constant. What is expectation of A? 0, right? 0 into cos omega t, and expectation of B is 0 times sine omega t. So the mean of xt is 0. Mean of xt is 0. So what is the condition for white sense stationary? The mean should be 0 or constant. Am I right? Are you with me?
Yes, sir.
Next, let us find out the autocorrelation function of ACF of xt. Let us check it. What is the autocorrelation function? R double x tau, that's equals to expectation of xt x t plus tau. This one we have to find out. So excuse me. Yeah. R double x tau is equals to expectation of xt is a cos omega t plus b sin omega t. This is xt, and xt plus tau is a cos omega t omega tau plus b sin omega t plus omega tau. Okay. So we have to multiply this expectation of, I'm multiplying and applying expectation parallelly. The first terms I'm applying a cos omega t plus tau. Okay. Cos omega t plus omega tau. So first one. Next, I'm going to multiply. I think it's a square. It is. It's a square. The first and the second is expectation of AB cos omega t sin omega t plus omega tau plus expectation of AB sin omega t cos omega t plus omega tau, and the last one b times b is b square sin omega t sin omega t plus omega tau. Now this is variance and this is 0, this is 0, and this is variance sigma b square. Okay, why it is expectation of a square is what? It's a mean square value, right? But I am writing a variance. In what condition mean square value and means variance are equal?
Mean is 0.
Mean is 0. Already is given that mean is given mean 0. So we can take the sigma a square sigma a square. Let us take let me write which is nothing but here itself. Let us write sigma square, sigma square. So we can take sigma square common, cos omega t, cos omega t plus omega tau plus sin omega t, sin omega t plus omega tau. Now we can apply cos A cos B plus sin A sin B formula. According to that, it is cos A minus B, right? So cos A minus B formula. Are we going correct?
Yes, sir.
Yes, sir.
Yeah. So anyway, A minus B is minus omega tau. Cos is even function. Write it. Okay. So R double X tau. Now we have seen that expectation of xt mean is 0. This is verified. And autocorrelation function is a function of tau only. Okay. So with this, what can we conclude? Xt is wide sense stationary random process. Okay. So far we have checked xt is whether the random process, the wide sense stationary random process or not. Now let us check for yt. So let us find out the mean of yt. What is the mean of yt? Expectation of yt. Expectation of what is yt? B, I think it is a b cos omega t minus a sin omega t. So apply expectation on the random variable. Expectation of b cos omega t minus expectation of a sin omega t. Anyway, the mean of b and mean of a are 0. Already those are given. So the mean of the random process yt is 0. Okay. Now let us find out autocorrelation function of yt. What is the autocorrelation function of yt formula? Expectation of yt y t plus tau. So r double y tau is equals to expectation of yt is b cos omega t minus a sin omega t. Yt plus tau is b cos omega t plus omega tau minus a sin omega t plus omega tau. Okay. That is multiply and apply the expectation. So expectation of b square cos omega t plus omega tau minus expectation of ab cos omega t sine omega t plus omega tau minus expectation of AB sine omega t cos omega t plus omega tau and minus into minus plus expectation of A square sine omega t sine omega t plus omega tau. So this is variance. This expectation of AB is 0, expectation of AB is 0, expectation of A square is variance of A. Both are having the same variance. Let's take them as sigma square. So on taking sigma square constant, it leaves us cos omega t plus omega tau and plus sine omega t plus omega tau. So sigma square, again we get the same formula, cos A cos B plus sin A sin B cos A minus B. So cos omega tau. This is R double Y tau. So the mean of yt, expectation yt is 0 and autocorrelation function of y is independent of time or it's a function of tau. So according to these two, we can say that yt is wide sense stationary random process. Yt is wide sense stationary random process. Is this enough to prove that xt and yt are wide sense stationary?
No, sir.
No. We have to check cross correlation of xt and yt. We have to check cross correlation of xt and yt. What is that? R xy tau. Okay, so R xy tau is a expectation of, the first one is xt, second is yt plus tau. So let us substitute R xy tau is equals to expectation of xt is a cos omega t plus b sin omega t, and coming to yt plus tau is b cos omega t plus omega tau minus a sin omega t plus omega tau. Now let us multiply and apply expectation. So on multiplying the first, we get expectation AB cos omega t plus omega tau plus, not plus, minus expectation of a square cos omega t sin omega t plus omega tau, and b times b is b square, so expectation of b square sin omega t cos omega t plus omega tau, and the last one expectation of AB sin omega t sin omega t plus omega tau, right? So So the correlation is 0, uncorrelated. So variance sigma square. This is variance sigma square, and this is 0, uncorrelated. So what is left? Let us write, and let us take sigma square common. So I think let us sin a copy minus cos a sin. Right. On taking sigma square common, so we are getting sin omega t cos omega t plus omega tau minus cos omega t sin omega t plus omega tau. I think it is a sin a cos b minus cos a sin a minus b. So omega t gets cancelled, and sin minus theta is minus sin theta. So let us write minus outside. It is minus sin square minus sigma square sin omega tau. Okay, so the cross correlation function is function of tau only and independent of time. Okay, now can we conclude that xt and yt are jointly Whitesian stationary? Given xt and yt are jointly Whitesian stationary random processes, because xt and yt are individually Whitesian stationary, and cross correlation function is independent of time, and it is function of tau only. Any doubt in this? Any doubt? Hello. Can someone give the answer? Three are there. Lunch చేస్తున్నారండి?
Yes, sir.
ఏంటి లంచ్ చేస్తున్నావా?
No, sir.
Okay. The next concept is cross correlation. Cross correlation. Already we have seen this. What is this? R x y tau is equals to expectation of xt y t plus tau. Now here in this we are going to discuss about the properties of cross correlation function. Properties of cross correlation function. R x y tau. R is correlation, xy represents cross. So the first property, Rxy minus tau is equals to Ryx tau. This one we have to prove. So how to prove this? First let us write the formula of Rxy tau. It is expectation of xt y t plus tau. Okay, now replace tau with minus tau, then we get rxy minus tau is equals to expectation of xt y t minus tau. Now let's take t minus tau is equals to k. Excuse me, madam. Okay, madam. Okay. Sorry, madam. Okay. Sorry, madam. లేదు మేడం. ఫార్వర్డ్ చేయండి మేడం. నేను ఈరోజు ఎవరైనా వెళ్ళారు మేడం ఇన్ఫర్మేషన్? సరే మేడం. సరే, థ్యాంక్ యూ. Yeah, so we can write expectation of x. T means k plus tau, and y t minus tau is k. So according to formula, let us rearrange this as expectation of yk times expectation of yk times xk k plus tau. Okay, can we write it as r? What is the first variable here? Y. What is the second variable? X. So function of tau. Okay, in place of t here we have k. Okay, except that t and k everything is same. Am I right? Are you getting? T plus lo k undante, remaining is same. The formula is same. Here you have k, here you have t, here k and here t. Remaining is same. Okay. So rxy minus tau equals to ryx tau. This is the first property. Any doubt in the first property? Answer ఇవ్వండి అమ్మా.
No, sir.
ఇదే క్లాస్లో ఉంటే వేరేలా ఉండదు. Second one, magnitude of rxy tau is less than or equals to square root of r double x 0 r double y 0. దీన్ని ఎలా ప్రూవ్ చేయాలి? మీరే సొల్యూషన్ ఇవ్వాలి. ఎలా ప్రూవ్ చేద్దాం? ఫస్ట్ ఆన్ ద రైట్ సైడ్ ఐఎమ్ రైటింగ్, రఫ్ గా రాస్తున్నాను. ఆర్ డబుల్ ఎక్స్ 0 అంటే ఏంటమ్మా? ఎక్స్పెక్టేషన్ ఆఫ్ ఎక్స్ స్క్వేర్ టీ కదా, అవునా కదా? టౌ ఈక్వల్ టు 0.
Yes, sir.
R double y 0 is the expectation of y square t or y square t plus tau. ఇక్కడ నేను t plus tau తీసుకోవాలనుకుంటున్నాను, ఎందుకంటే క్రాస్ కొరిలేషన్ ఉంది కాబట్టి y అనేది t plus tau లో ఉంటుంది. ఓకే, సో నాకు ఏం రావాలి? ఎక్స్ స్క్వేర్ రావాలి, వై స్క్వేర్ రావాలి. ఇలా రావాలంటే ఏం చేయాలి? Can we use a plus b whole square formula? Means xt plus yt plus tau whole square. Can we use that? xt plus y t plus tau. నాకు స్క్వేర్ రావాలంటే I have to do this. అవునా? x square రావాలి, y square రావాలంటే I have to apply this xt plus yt plus tau whole square. ఇది అప్లై చేస్తేనే నాకు స్క్వేర్ వస్తుంది. అవునా కదా? ఆన్సర్ ఇవ్వండి అమ్మా.
Yes, sir.
ఇంకోటి ఏం మిస్ అవుతుంది? ఎక్స్పెక్టేషన్ మిస్ అవుతుంది. అంటే దీనికి ఎక్స్పెక్టేషన్ అప్లై చేయాలి. Can someone tell me what is expectation of the square? Is it not mean square value?
Yes, sir.
It's a mean square value, right? So mean square value is always greater than or equal to 0. In this, I am including alpha. Okay, I am including alpha. Is a mean square value. I have written mean square value of y t plus tau plus alpha xt. The above statement is this one. Okay, now let us do that. Expectation of alpha square x square t plus y square t plus tau plus 2 alpha xt y t plus tau is greater than or equals to 0. Now let us apply expectation. Alpha is some value, it's a real number, it's a constant, so you should not, it's not a variable, it's not a random variable, so you should not apply expectation on alpha square. You have to apply expectation on x square t and expectation of y square t plus tau plus 2 alpha expectation of xt y t plus tau greater than or equals to 0. Now coming to this, this is r double x 0 and this is r double y 0 and this is rxy tau, right? So let us write that alpha square r double x 0 plus r double y 0 plus 2 alpha rxy tau greater than or equal to 0. Let us say equation 1. Okay, now we have to let us take it as a phi. Let phi equals to alpha square r double x 0 plus r double y 0 plus 2 alpha r xy tau. Now I would like to find at what value of phi this alpha you get 0. It is 0. Did you observe that 0 is greater than or equal to 0? Greater than or equal to 0. 0 means a minimum value, right? Did you observe that greater than or equal to 0? So to what are the stationary points? Stationary points and minimum points, maximum points ne stationary points antam kada.
0,
right?
infinity.
Okay, minimum points and maximum points are called stationary points. How do we find the stationary points? We have to differentiate and equate it to 0. But I'm going to do that. So we have to do d pi by d alpha is equals to 0. At what value of alpha this equation becomes 0? That I'm going to find out. So d pi by d alpha is the 2 alpha r double x 0 plus 2 r xy tau is equals to 0. From this, alpha is equals to minus r xy tau by r double x 0. Let us write equation 2. Let us substitute this equation 2 in equation 1. Substitute alpha in equation 1. So what is equation 1? Alpha square r double x 0. Alpha square is nothing but r square xy tau by r square double x 0 times r double x 0. And the second one is r double y 0. It is as it is r double y 0 plus 2 alpha. Alpha is minus r xy tau by r double x 0 times r xy tau or xy tau greater than or equals to 0. So here r xy double 0, r xy 0 and 1 r double x 0 gets cancelled. So what it leaves us, r double y 0 r square xy tau by r double x 0, and there is one more minus 2 r squared xy tau by r double x 0. So it leaves us r x y r square xy tau by r double x 0 greater than or equals to 0. So r double y 0 greater than or equals to r square xy tau by r double x 0. So we can write it as r square xy tau less than or equals to r double x 0 r double y 0. So on taking square onto the right side, it becomes plus or minus. So I'm going to represent the plus or minus with mod. Okay, so less than or equals to square root of r double x 0 r double y 0. So this way you have to prove. The third one, it is also about the magnitude of cross correlation function. This time we have to prove that it is a half of r double x 0 plus r double y 0. It's average. The magnitude this time is average of r double x 0 and r double y 0. We have to prove that. This time I am going to find out the mean square value of xt and yt plus tau. Xt plus y t plus tau. What is this? Expectation of xt plus y t plus tau whole square. Mean square value is greater than or equals to 0. Let us apply a plus b whole square formula. X square t plus y square t plus tau plus 2xt y t plus tau greater than or equals to 0. So apply expectation operator on individual terms. First one is expectation of x square t. Second one is expectation of y square t plus tau. And third one is 2 times expectation of xt y t plus tau greater than equals to 0. So first one is r double x 0. Expectation of x square is r double x 0. Second one, expectation of y square t plus tau is r double y 0. And the third one is expectation of xt and yt plus tau is cross correlation, right? rxy tau greater than equals to 0. So r double x 0 plus r double y 0 greater than equals to minus 2 times rxy tau. Otherwise we can write it as rxy tau less than equals to minus half of r double x 0 plus r double y 0. Apply mod on both sides, then it is r mod rxy tau less than or equals to half of r double x 0 plus r double y 0. Okay. The fourth property is if xt and yt are independent random processes, xt and yt are independent random processes, then can someone tell me what is the rxy tau? We can write it as expectation of xt times expectation of y t plus tau. Okay. So how do we prove it? Let us write the first formula of cross correlation function. It is expectation of xt y t plus tau. So let us write this one in terms of integration. So limits are from minus infinity to plus infinity. Xt x t plus tau, and here we have to write a second order density function f x comma y colon t plus tau. One is dx, this is not x, this is y. You are just seeing, or where are you? I wrote x, you are not telling. So y dy. When two random variables are independent, then how can we write this x comma y colon t plus tau? What is independent condition? Multiplication of individual density functions. Am I right? So let us apply this. This is independent condition. On applying that, integration from minus infinity to plus infinity, integration from minus infinity to plus infinity, xt y t plus tau fx colon t fy colon t plus tau dx dy. Let us separate these integrations. Integration from minus infinity to plus infinity, xt fx colon t dx. Another integration is integration from minus infinity to plus infinity, y t plus tau f y t plus tau dy. So what are these formulas? What is this? Is it not expectation of xt? And this integration is expectation of y t plus tau. So finally, r xy tau cross correlation is equals to expectation of xt times expectation of y t plus tau if xt and yt are independent random processes. Okay. Sir, are you there?
Yes, sir.
Tell me the absentees numbers.